It is February 3rd, 1943, and the Kaiser Shipyard in Richmond, California, is roaring under electric light long after the sun has gone down. A crane, the height of a 10-story building, swings a prefabricated hull section through the darkness, sparks cascading from welding torches like a shower of orange rain. Workers in oil-stained overalls, many of them women who had never held a tool before the war, move between the ribs of a half-finished Liberty ship with the practised choreography of a factory line. 4 days from now, this vessel will be launched. 4 days. Before the war, building a ship of this size took the better part of a year. 6,000 miles to the east, in the Ruhr Valley, a very different scene is unfolding. Krupp's steelworks at Essen labor under blackout conditions, their furnaces starved of coke, their skilled workforce steadily bled away by conscription to the Eastern Front. Foremen juggle production quotas that shift weekly according to whichever theater of war has become the most desperate. There is no equivalent of Richmond here, no city built from nothing to build ships from nothing. There is only a finite country trying to feed 2, and eventually 3, fronts with a single industrial base that was never designed for it. This is the story of how one nation manufactured the capacity to fight across 2 oceans simultaneously, while another, technically brilliant and fanatically driven, could not sustain even one land front without cannibalizing itself. It is not, at its heart, a story about tanks or aircraft or the men who flew and drove them, extraordinary as their courage was. It is a story about coal, steel, oil, ball bearings, and the ruthless arithmetic of total war, and it explains, more than almost any single battle, why the Second World War ended the way it did. Understanding why matters, because the popular memory of the war tends to fixate on generals and battles, on Normandy and Stalingrad and Midway, as though the outcome hung on tactical brilliance alone. It did not. Beneath every campaign lay a colder calculation of who could produce more, faster, and for longer. America's answer to that calculation would prove decisive. The problem facing Germany in 1939 was, on paper, invisible. Adolf Hitler had inherited an economy that Nazi propaganda insisted was fully prepared for war, and, in the narrow sense of equipping an army to win short, sharp campaigns, it largely was. The Wehrmacht that swept through Poland and then France possessed excellent tanks, superb close air support, and doctrine that outpaced its opponents. But this was a military built for what German planners called blitzkrieg, a strategy of concentrated, decisive victories precisely because Germany's economy could not sustain a long war of attrition. The country possessed roughly 1/10 the coal reserves needed for sustained heavy industry compared with what its ambitions required, and critically it had almost no domestic oil. Romania's Ploiesti fields would become Germany's single most important source of petroleum, and the Allies knew it, which is why those refineries would eventually be bombed with a persistence bordering on obsession. Germany's deeper problem was structural. Albert Speer, appointed Minister of Armaments in 1942, inherited a system riddled with duplication, rivalry between the Army, Navy, and Luftwaffe procurement offices, and a labor force increasingly dependent on forced and slave labor from occupied territories, workers who had no incentive to produce quality goods and every incentive to sabotage what they could. Even at Speer's most efficient, in 1944, when armaments production reached its wartime peak, Germany produced fewer tanks in the entire year than the United States built in a handful of months. The Reich never approached anything resembling the excess capacity, the reserve, that a 2-front or 3-front war demanded. Every division sent east was a division not defending the west. Every fighter squadron protecting the Reich's cities was a squadron absent from the Mediterranean. There was also the question of raw materials that no amount of engineering brilliance could substitute for. Germany imported roughly 2/3 of its iron ore from Sweden, a supply line that remained vulnerable throughout the war and that Allied planners repeatedly discussed severing. Rubber, essential for every lorry tire and aircraft component, had to be synthesized at enormous cost through the Buna process, since Germany possessed no rubber plantations of its own, unlike Britain and America, who could draw on colonial and allied sources: manganese, tungsten, chromium, nickel. The list of strategic materials Germany lacked in sufficient quantity reads like an inventory of everything modern warfare actually requires. Hitler's invasion of the Soviet Union in June 1941 was driven in no small part by a hunger for exactly these resources, for the Caucasus oil fields and the Ukrainian wheat belt, a gamble that succeeded only in opening the very second front that would eventually help finish the war. By the time German planners recognized the scale of their material shortfall, the war had already grown too large to solve it through conquest alone. Then there was the question of time. Germany's war economy was, in the memorable phrase used by several post-war historians, one of planned improvisation, lurching from crisis to crisis, prioritizing whichever weapon or shortage seemed most urgent that quarter, rather than building the kind of deep, redundant industrial base that could absorb sudden losses. When Allied bombing began systematically targeting ball-bearing plants at Schweinfurt in 1943, the entire German war machine shuddered, because so much production depended on so few factories. America possessed no equivalent single point of failure. Its industrial base was so widely dispersed, from California to Michigan to Pennsylvania, that no conceivable bombing campaign, had one been possible across the Atlantic, could have touched more than a fraction of it at once. Contrast this with the United States in December 1941. America was not unprepared by accident. It had spent 2 years watching the war in Europe and had already begun converting its civilian industrial base under the Lend-Lease framework, supplying Britain and the Soviet Union before it had even entered the conflict itself. But Pearl Harbor changed the scale of ambition entirely. Suddenly, the United States needed to arm and supply not merely allies, but two of its own vast military campaigns running in opposite directions across the globe, one across the Atlantic to defeat Germany, one across the Pacific to defeat Japan, each separated from the other by thousands of miles of ocean and requiring entirely separate supply chains, shipping routes, and logistics networks. On paper, this should have been an impossible strain. In practice, it revealed something extraordinary about the underlying capacity of American industry that had simply never been tested at full throttle. The architects of America's production miracle were not glamorous figures. Men like William Knudsen, the Danish-born former president of General Motors who was appointed to head war production, and Henry Kaiser, the construction magnate who had never built a ship in his life before 1940, and who would go on to build more of them than any man in history, approached the problem the way industrialists approach any problem: standardize, simplify, and scale. The War Production Board, established in January 1942, coordinated the conversion of civilian factories, automobile plants that had built Buicks now built tank destroyers, typewriter manufacturers turned out rifles, and a vacuum cleaner company found itself producing gas mask components. The single most revealing example is the Liberty ship. Britain had commissioned a simplified cargo vessel design from American shipbuilders in 1940, desperate for tonnage to replace losses from U-boat attacks. Kaiser's yards took that basic design and applied assembly line principles borrowed directly from Detroit. Rather than building a ship from the keel up as a single continuous process, sections of hull, prefabricated in pieces weighing up to 250 tons, roughly the weight of 30 double-decker buses, were welded together in enormous jigs and then lifted into place by crane, dramatically compressing the timeline. Welding itself was part of the innovation. Traditional riveted construction, which required years of skilled apprenticeship to perform properly, was replaced almost entirely by welded seams that could be taught to a new worker in a matter of weeks. This single substitution, welding for riveting, is difficult to overstate in importance because it meant the workforce building America's wartime fleet did not need to be drawn from a small pool of veteran shipwrights. It could be drawn from anyone willing to learn, and millions of Americans who had never set foot in a shipyard before 1941, many of them women recruited under the same drive that produced the cultural icon of Rosie the Riveter, did exactly that. The average Liberty ship took around 42 days to build by 1943. The record, set at Kaiser's Richmond yard in November 1942, stood at 4 days, 15 hours, and 26 minutes, a stunt undertaken partly for propaganda purposes but built on genuinely repeatable methods. Each completed vessel measured around 135 meters in length, roughly the height of a 30-story building laid on its side, and could carry about 10,000 tons of cargo, enough to transport several hundred tanks or millions of rounds of ammunition, or enough food to feed a small city for a month. Across the war, American yards launched roughly 2,710 Liberty ships alone, not counting the thousands of other vessel types, an output so vast that German U-boat commanders eventually reported, with something approaching despair, that they were sinking tonnage more slowly than it was being replaced. The same philosophy of standardization and dispersed mass production applied almost everywhere else in the American war effort. Willow Run, a purpose-built Ford factory outside Detroit, was constructed specifically to manufacture B-24 Liberator bombers using automotive assembly line techniques, at its peak turning out a completed aircraft roughly once an hour, a rate that stunned even the engineers who designed the plant. Henry Ford's production planners broke the bomber down into components that could be built by workers with only basic training, much as Kaiser had done with ships, and the factory itself, at over 3 million square feet, was at the time the largest manufacturing building under a single roof anywhere in the world, comparable in floor area to roughly 50 football pitches. Detroit's automobile plants more broadly converted almost wholesale to war production between 1942 and 1945, and the phrase "arsenal of democracy," coined by President Roosevelt in a radio address in December 1940, captured precisely what these factories became, not merely suppliers of equipment, but the industrial backbone underpinning every Allied theater of the war simultaneously. Ships were only the visible tip of it. American factories built roughly 300,000 aircraft during the war, compared with Germany's approximately 120,000. They produced around 88,000 tanks against Germany's 44,000, despite many American tanks, the Sherman among them, being technically inferior in armor and firepower to their German counterparts. The difference was never really about which tank was better in a duel. It was about which side could afford to lose one and simply send another, and another, and another, while the enemy's replacement arrived months later, if it arrived at all. This was the brutal, unglamorous mathematics of industrial war, and it is impossible to overstate how thoroughly it dictated the war's outcome long before the final campaigns of 1944 and 1945 played out on the ground. The practical result of this capacity was a military machine that could fight in the Solomon Islands and in the hedgerows of Normandy in the same month, supplied by separate fleets, separate depots, separate manufacturing schedules without either theater starving the other. In the Pacific, the island-hopping campaign of 1943 and 1944 depended on a staggering logistics operation. Forward bases constructed from nothing on Guadalcanal, Tarawa, and later Iwo Jima and Okinawa, each requiring its own airstrips, fuel depots, and hospital facilities, built by construction battalions, the famous Seabees, often under fire. These men could reportedly carve a functioning airstrip out of raw jungle in a matter of days, a feat of combat engineering that depended entirely on a steady supply of bulldozers, steel matting, and fuel arriving by sea, week after week, from factories thousands of miles away. Simultaneously, the buildup for Operation Overlord in Britain required the transport of roughly 2.5 million American servicemen and 16 million tons of supplies and equipment across the Atlantic, an undertaking so vast that southern England was only half-jokingly said to be sinking under the accumulated weight of materiel. Convoys crossing the Atlantic in 1943 and 1944 sometimes numbered over 100 merchant vessels at once, escorted by destroyers and newly available long-range aircraft that had finally closed the mid-Atlantic gap where U-boats had once hunted freely. Meanwhile, in the Pacific, the logistics challenge was arguably harder still, since distances there were measured not in the 1,000 or so miles between New York and Liverpool, but in the 10,000 miles or more separating California from the forward edge of the fighting near the Philippines, a supply line that had to be defended, refueled, and resupplied at every link. Both campaigns drew on the same national production base, and neither, remarkably, was left wanting for want of the other. Records from the period, particularly quartermaster logs and after-action reports held in American military archives, document specific instances where equipment arriving fresh from stateside production lines reached frontline units within weeks of manufacture, a turnaround that German logisticians, dependent on rail networks increasingly disrupted by Allied bombing, could rarely match. Exact figures on how much this speed shortened individual campaigns remain difficult to establish with precision, and historians are cautious about crediting logistics alone for tactical victories that also depended on planning, intelligence, 2 oceans, 1 nation, 1 uninterrupted flow of steel and men and machines, 1 front, 1 nation, forced by its own limitations to rob 1 battle to pay for another. The war was decided in more places than the beaches of Normandy and the islands of the Pacific. It was decided, quietly and relentlessly, in Richmond and Detroit and 1,000 converted factories across America, long before most of the ships they built ever saw a single shot fired in anger. That is the arithmetic that ultimately mattered. That is the story that the tanks and the aircraft and the medals so rarely tell.